මව්බිමට දෙවැනි කොට සිතන්නෙමු දෙව්ලොවේ නැති අසිරි මව්බිමේ දකින්නෙමු පරිසරය රකින්නෙමු වඩන්නෙමු වවන්නෙමු මේ පිළිනයෙන් සදා මව්බිමට බැඳෙන්නෙමු
Welcome to the Solve Climate Global Dialogues. You're participating in one of 125 events held across the planet, including in almost all 50 U.S. states, part of a global project called Solve Climate by 2030. My name is Eben Goodstein, and I'm an economist and director of the Graduate Programs in Sustainability at Bard College in New York, the lead organizer for Solve Climate. This last year has been difficult for everyone. As the world looks forward to recovery from COVID, we are focusing tonight on the most important question facing humanity. What can we do in this year in our regions to help solve climate change while supporting struggling communities that have faced widespread loss of life, economic disaster, and joblessness? Worldwide, from Australia to Kyrgyzstan, from Colombia to Malaysia, and from South Carolina to South Africa, Solve Climate audiences are hearing from local experts and young leaders about concrete steps that can really help nations solve climate change while creating much-needed jobs and incomes for everybody. The year 2020 was one of the two hottest years in human history, bringing with it massive forest and grassland fires, record-breaking storms and hurricanes, and relentless rising seas. Solving climate is the challenge which the human species must now face. There's hope for the future. Solutions have continued to advance. This year, China committed to building a carbon-neutral economy, while the U.S. rejoined the Paris Agreement. Solar, wind, and battery prices continue to fall, while major car companies have been rushing to electrify the global fleet. Worldwide, movements for Black Lives Matter and Me Too are leading in bringing much delayed and urgently needed justice to the world. Time is short. We have until 2030, 10 years to solve climate. We can get a lot done in this decade. We have the solutions, but only if we focus the world on climate solutions and justice, and then do the work we have to do in our own cities and regions. For students listening, you are the leaders. Without you, the future we envision will not come. I'm asking tonight for your help. We're going to discover powerful ideas for climate solutions and climate justice and how you can be a part of the solution. But this message must reach beyond those of us who are listening right now. Would you ask all your teachers this week in every subject to make climate a class? The teacher can assign tonight's webinar's homework for the students and then afterwards have a one-class period discussion. And we mean every subject, from art to engineering, psychology to business, dance to chemistry. Teachers don't need to be a climate expert to lead a discussion about climate change. The Solve Climate project has easy-to-use teacher's guides in nearly every subject and in 3 languages to help teachers make climate relevant to their class. It only takes courage. Don't take no for an answer. Ask them, why not? This is your future. You'll be surprised how many teachers will say yes and thank you. Imagine you, thousands of leaders like you around the world asking their teachers once every school term to make climate a class. That means every term going forwards, hundreds of thousands, millions of students worldwide in their classes talking about climate solutions. COVID has shown how fragile our global economy and society are to extreme events. It's also shown that vulnerable people are facing the hardest, most damaging impacts. This is also true with climate change. Science has made it clear that unchecked, global warming will mean an unending onslaught of extreme events, causing untold suffering for humanity and all creatures, species driven to extinction, a planet of environmental refugees. And yet, in many ways, this is the most exciting time to ever be alive as a human. We have the tools and networks and technologies to rewire the world with clean energy, reimagine the global food system, reinvent transportation, and regenerate forests and grasslands, and be well on our way to solving climate by 2030. Tonight, we will learn how to do this in our own cities, our own towns, our own regions. Thank you for the work you will do to promote climate solutions and a just world.
Thank you everyone for joining us today on this the regional dialogue on climate solutions for South Asia, which is happening today, tomorrow, and day after tomorrow from 5 p.m. till 7 p.m. Sri Lankan time. And today we are going to have the sessions on, for the first day, on is climate change happening, evidence from weather variability in Sri Lanka. There will be 3 sessions basically, which are mainly focusing on understanding climate change and its effects. So the first session will be on is climate change happening, evidence from weather variability in Sri Lanka, which will be presented by Dr. Mahesh Edrusinghe, who is the senior lecturer at the Department of Physics, University of Colombo, Sri Lanka. The second session will be climate change in South Asia, current status, projections, and sectoral risks, which will be presented by Mr. S.C. Bahan, Regional Coordinator, Agrometeorology, and Head of Power, Health, and Transport Sector Applications from India Meteorological Department, New Delhi in India. And the third session will be done by Mr. Maharam Dakua from Civil and Environmental Engineer, who is a civil and environmental engineer and consultant in water supply, sanitation, waste management, and climate change adaptation from Bangladesh, who will be doing a session on climate resilience in water, agriculture, and health systems, planning and participation. So these will be the 3 topics. I will introduce the speakers when the sessions will start. And I just want you to remind everyone who is participating in this regional dialogue, please try to post questions in the chat box anytime, whenever you feel you have a question in your mind. You don't need to wait until the end of the session. You can just drop few lines in the chat box. So we will keep on collecting all the questions, and then when we go for the final discussion round, we will take all the questions, and then we will have a fruitful discussion. And I just want to also say that this event is hosted by International Journal of Climate Resilience with the Center for Environmental Policy, Bard College from United States of America, and under the theme of Solve Climate by 2030. So welcome everyone to the first day of those 3 days event. And then I'll be moderating this session. My name is Aslam Sajjad. I work as a lecturer at the Southeastern University of Sri Lanka, Faculty of Engineering in Oluville in Sri Lanka, which is in the eastern coast of Sri Lanka. And I'm also one of the editors of International Journal for Climate Resilience. And I have I've been doing research on disasters as well as climate change in Sri Lanka, and also in my other colleagues in South Asia as well. So I'm happy to be a moderator for this session. So please post your questions, and I welcome all of you for this webinar, and I hope everybody will contribute with your questions, and also we will be discussing, taking those questions, and to keep all of us interactive with each other with the discussion at the end of the sessions. So let us directly go to the sessions. I think so. Please keep your mics muted. So some logistics all the time. If you feel any questions, please post it in the chat box. So let's directly go to the first session. Do you have anything else, Dr. Noble? If not, then I will introduce the first speaker.
Yes, Saja, please go ahead.
Right. So let me invite Dr. C. Mahesh Edrisinghe, who is the senior lecturer from Department of Physics, University of Colombo, Sri Lanka, who is also a specialist in lightning climatology, natural disaster management and mitigation, and lightning and surge protection and transient analysis. And let me give a brief introduction of our first presenter, Dr. Edrisinghe. Dr. Edrisinghe joined the Faculty of Science, University of Colombo in 2002 as an academic, and currently he is the faculty member in physics attached to the Department of Physics. He received his Bachelor of Science Honours Special Degree in Physics from University of Colombo in Sri Lanka in 1997 and a PhD in Instrumentation Physics with special attention to lightning climatology and lightning protection, and a split research program between University of Uppsala, Sweden and the University of Colombo in 2007. He completed his MBA from London Metropolitan University, UK in 2016. He has served as the Commissioner of Sri Lanka Inventors Commission, Ministry of Science, Technology and Research from December 2015 to November 2018. And Dr. Edrisinghe was the President of Section E1 Physical Sciences Sri Lanka Association of Advancement of Science in 2012 and the Joint Secretary of Institute of Physics from 2007 to 2010. And Dr. Mahesh Edrisinghe was a member of the Board of Management and the Director Board in several government institutions, including Sri Lanka Sustainable Energy Authority, National Science Foundation, Institute of Human Resource Advancement. He was a member of the Sectoral Committee on Electronics Engineering, Sri Lanka Standard Institution, and the National Standards Body of Sri Lanka. So that's a brief description of our first speaker, Dr. Edrisinghe. And now I invite Dr. Edrisinghe to start his presentation.
Yeah, thank you, Dr. Aslam Saja, and thank you for the kind introduction. Dr. Novil, can you give me the permission to share the slides, please?
Yes, I have given.
Great.
Yes.
Okay, so just give me 1 minute. Okay, hope everyone can see the screen. Dr. Novil, can you see the screen? Is it?
We are not yet seeing your screen.
Yes, we can see now.
Okay. Okay, there must be a small time gap. So,
we can see now, yeah.
Yeah, great. So first of all, let me thank Dr. Novil and his team. So I should thank Dr. Novil for inviting me for this session, and Dr. Novil and your team is doing a great job for arranging this one. So under this regional dialogue for climate change solutions for South Asia, being the first speaker, I am not going to do a routine presentation here today, but I'm going to raise a question. So the question is climate change happening? So we all talking about the climate change everywhere, and this must be due to climate change and so on. So my question is it really happening? And how can we use the Sri Lankan context, our own experiences, our evidences, to couple with that one? So my topic will focus on the evidence from weather variability in Sri Lanka. So at the end, whether we can discuss these evidences, whether we can cooperate or whether we can couple together with this question and to find an answer. So even though it's a very complex topic, let's discuss some of the experiences that we are having and some results we have observed during last few years results. So basically, today I'm going to present two of my PhD students, Niranga and Madhuranga's work, a combination of these two works to find the answer of this, whether the climate change is happening and how we can incorporate our own evidence, basically from the weather variability. So under today's session, I'm going to discuss about lightning, drought, and rainfall. You know this, when you are talking about the climate change, it's a really big subject. It's a very vast subject. So I have narrowed down to three pillars under this climate and weather: lightning, rainfall, and drought. So what matters as a human being, as a general public person, what immediately what we respond is for the disasters, natural disasters. That is what immediately we can feel. So when it comes to the natural disasters, it is happening all over the world in different platforms, different framework, different sizes, all these things. But the real issue is there is a discussion, there were some evidences, there were some conclusions that scientists are claiming these natural disasters are mostly due to the climate change or to the weather variability. So my question is whether it is true or there are some other aspects. Definitely, yes, some kind of sometimes the land use, urbanization, likewise. So we can discuss in later. Then when it comes to Sri Lanka, we are having different identified natural disasters, floods, strong winds, drought, heavy rain, and of course, lightning. And being in a tropical country, hazards due to lightning, we have identified as the one of the dominant natural hazard in Sri Lanka. Why? I will show you at the end of today's presentation, because I will show you some of the facts about the lightning hazard and somewhat similar to the lightning hazards, definitely. And the floods, drought, there were some damages, so we can discuss openly. So starting from, to give you an overview of Sri Lanka, we are having two monsoon seasons, southwest and northeast monsoon seasons. Then we have first intermonsoon season and the second intermonsoon season. Most of the scientists who are dealing with this climate and weather-based studies, mostly we refer these monsoon seasons. In addition to that, in Sri Lanka, we are having 4 climatic zones. We have the dry zone, wet zone, intermediate zone, and semi-arid zone. And in addition to that, in Sri Lanka, just for the administrative purposes, we are having 25 administrative districts and as well as 9 provinces, central, western, Sabaragamu, southern, likewise. So if you have a look at this right side map, here you can see that if you take like this area, you can see the district number 8, that is Hambantota. But according to this map, you can see Hambantota district, it covers, it consists of a certain part of the semi-arid zone. Then we have the intermediate zone as well as the dry zone. And if you take the district number 22, which is the Puttalam, and you can see again semi-arid, intermediate, and of course the wet zone as well. So it's some kind of a complex situation, but we are Sri Lankans, we are get used to this area. Now, if you have a look on the annual rainfall in this Sri Lankan context, you can see here, if you take the dry zone, the average rainfall is 1,520 millimeters, and it varies between 2,255 to 990. And if you take semi-arid, it is, you can see the 1,264 to 1,264 is the average. So if you take the wet zone, which is the western part of the country, you can see the maximum annual rainfall is around 3,719. So that is the rainfall scenario in Sri Lanka. So today's session, I'm not going to talk about the rainfall. What matters for us is nothing to do with the rainfall as far as we identified. What matters is how this rainfall is changing. So we will show you some of the results that we observed as the rainfall trend. There's a significant trend in rainfall. If you take year-wise, there's a change. And let's see whether we can couple these changes to find out the answer for our original question. So we are trying to find out whether the climate change is really happening or not. Right, so moving to the next slide. So you can see again this twice annual rainfall. Jaffna, Kilnochi, Manala area, it's around 1,000. But if you go to Kalambu, Kalutara, Gaul-like districts, even Kegol-like districts, almost like 3,000 millimeters as the annual rainfall. So there is even though Sri Lanka is a very small country, you can see there is a vast variation is there within the different districts, right? So as an example to talk about this rainfall trend, you can see here I have chosen two districts, Hambantota district and Kalutara district, to have an idea about this, how this rainfall is changing in terms of annual and based on 4 monsoon seasons. So just to give you an idea about the district number 8 is the Hambantota, and district number 10 is the Kalutara, right? So district number 8 is mostly under semi-arid zone. District number 10 is mostly at the wet zone. So now let's see how the rainfall trend is. So if we take from 1989 to 2019, if you take Kalutara district, in annually you can see the rainfall is increasing. And surprisingly, you can see, even though Hambantota and Kalutara district are in 2 different zones, wet zone and the semi-arid zone, you can observe the rainfall trend is increasing. So there is an increasement of rainfall trend over time. So even though we talk about the semi-arid zones with less rainfall, but you can observe it is increasing, right? So if you take the northeast monsoon season, you can see it's little bit steady in Hambantota district as well as the northeast in the Kalutara district. But if you take the annual, you can see it is varying between, let's say, 2,600 to close to 3,500. But if you take Hambantota, it is increasing between 1,200 to 1,600 approximately, these values. So you can see it is increasing. Now, if the rainfall is increasing over time, are we in a position to say that the climate change is happening? Because our perspective is, if rain is not there, we used to say, okay, now there is a climate change. But what I'm going to emphasize here is, it is not only the rainfall matters for the climate change. So I will show you later. Right. So moving on to the next slide. Now, if we take the zonal wise, the wet zone, dry zone, intermediate zone, and the semi-arid zone, there also you can see the rainfall trend is increasing. Right. So these are one of our recent findings. So even the wet zone and even at the intermediate, even at the semi-arid zone, rainfall is increasing over time. Right. But the amount is a little bit different, but the scenario is everywhere rainfall is increasing. Okay, that is about the rainfall. Now, the major outcome of this study you can see here. If you take Jaffna, Batikalo, Kilnochi, and Ampara-like districts, you don't notice these increases, right? And then if you take the wet zone, you can see a significant increase in the southwest monsoon rainfalls. Right? But if you take northeast monsoon, 40% of the district in Sri Lanka showing the negative trend, and the 60% is showing the positive trend. So if you take district wise, the scenario is little bit different, right? So here we talk about, in the previous slide, we talk about the zonal wise, and two districts as an example. But as I told you before, the zonal wise, there are some districts overlapping between these the zones. So some district wise, you can observe a negative trend, right? Major highlighting, right? Now, based on our findings, this is very important, that we have observed the dry zones and intermediate zone margins are slightly now changing. So that is what we call climate change, right? So now the zonal classification, the area wise, the margins are now slightly changed, right? And if we take the annual and seasonal wise, when you see the rainfall increasing, right, there is a trend of increasement of this rainfall, and that will definitely drive you for the floods. For example, according to our findings, in near future, southern and western provinces are in high risk level for floods. However, when you go to the eastern side or the southeastern districts, you may face severe droughts in the future due to declining of rainfall in annual, or the basically mostly in the northeast monsoon season. Okay, so now there are different facts we can think about, right? So we discuss about rainfall. Now let's come to discuss the droughts. Before we move into the drought section, let me say something, some basics of the droughts. We have 4 drought types: meteorological, agricultural, hydrological, and socio-economic droughts. Actually, these 4 droughts are interlinked. For example, agricultural droughts may occur after meteorological droughts, likewise, right? So now, if you take this map, right, you can see 2012, 10, 16, 14. Actually, in Sri Lanka, we are having this Yala and Maha season. So they are in 2012, 10, 16, 14, we have the Yala and Maha 6-month period. And you can see, according to our historical data, in 2010, which we discussed, which we declare as a non-drought year, right? In 2010 is the second row of this map. you can see it is almost extreme wet condition. If you take 2010 August, Sri Lanka is almost like extreme wet, right? But if you take 2012 May, you can see it is extreme dry or severe dry situation, right? So actually in 2012, Sri Lanka has declared as a drought year. So for Sri Lanka, it was a drought year in 2012. And you can see in this map, it is very easy to understand, right? So basically, in the yellow season, we had a severe economic impact. And when it comes to the Maha season, you can see 2000, the last row, 2014 to 2016, this you can see 2014 December, the country is almost full. So it is changing, right? It is changing. Now, for an example, in the previous figure, we discussed 2010 as a noun drought and 2012 as a drought year. So you can see here, 2010 is almost greenery look. But if you take 2012, you can see the extreme drought areas toward the northern side is there. Okay. And okay. Now, this is another classification that we have declared based on our findings. You can see the meteorological and agricultural drought hazards in Sri Lanka, and the red color districts indicates as the high hazard level, right? So Anuradhapura, Monragala, Ampara. So those are like high hazard level districts for meteorological. But if you go to agricultural droughts, you can see the red color, and the brown color is all over the country towards the northern, eastern, and the southeastern side, right? So, but if you come to the western part, you can see most of the districts are no drought districts for the both meteorological and agricultural drought hazard levels. Okay. So, based on these findings, we can say now with the help of these two hazard levels, we can plan our crop. Perhaps we can introduce some new drought tolerant crops or change the crop patterns, right? Maybe we can change minor changes for the growing seasons, Yalamaha. And if you take the last few decades, people talking about this, the deforesting. Of course, if you take the land use map and the greenery map, of course, you can observe these things, right? So these may have caused some significant impact towards the increasing of these droughts, right? On the other hand, as we discussed before, there is an increasing trend of annual rainfall trend, right? So let's keep those things in mind to find out the answer for the original question. So when it comes to the lightning accidents, right, you can see the accidents comes into the picture in two aspects. One is the property damage, and the other one is the human damage. So you can see the number of deaths and the injuries. Right? In some of the districts, it is dominating, right? And for some of the districts, it is not over, right? And for the property damage, of course, you can see the some of the districts it is dominating, some of the districts it is not there, right? So here in this graph, what I want to emphasize here is you can see the red line, that is the lightning flash density. Lightning flash density means per square kilometer per year, how many lightning flashes may occur, right? So, for example, in April, you can see it is almost more than 30 lightning flashes per square kilometer per year, right? And you can see in April, you can the number of deaths, injuries are recorded with its highest numbers, right? Okay. And if you take the monsoon seasons, you can again see the first is the monsoon season, and the second, you can see the death injuries. So these are just an overview. Okay, so moving to the next slide. Then from 1974 to 2019, number of accidents happened in Sri Lanka due to lightning. You can see there is an increasing trend. This is a cumulative graph, but you can see it's a sudden increasement. So in this graph, you can see after 2000, there is a significant increasement. So can you couple this increasement for the this weather variability, and will it be some kind of a resultant scenario due to climate change? So there are a lot of things to discuss. And just to give you an overview of lightning accidents in Sri Lanka with distribution of the lightning flash density in Sri Lanka, you can see towards these red hotspots are with the highest lightning flash density in Sri Lanka. And if you take the monsoon seasons, you can see the first intermonsoon season. You can see you are having highest number of lightning flash density, right? And then you can see the southeastern monsoon and the southwest monsoon, those are with less. And here also you can see, even though the lightning flash density is very, very low in some of the seasons, still you can have the lightning accidents, right? And these are annual variation. Each the figure A, this is for the January, and figure D, this is for the April. So you can see the March, April, and October, November. You can see high lightning flash density, and but the lightning accidents is all over the year, right? So and then here you can see the district overview. You can see some of the districts having a very high number of lightning accidents. Some of the districts is almost low. The green color districts are lower numbers, right? And this is for the elevation, right? So you can see the different elevation sizes, and the figure number B, you can see most of the lightning flashes occurred in Sri Lanka is at the coastal level, or between 0 to 150 meter level, right? So this is also the somewhat similar graph, similar map that is referring the lightning flash density by coupling the monsoon seasons. And you can see the higher the elevation, the lower number of lightning flashes has been recorded in Sri Lanka, right? Give you an overview about lightning accidents, right? So if you take Sri Lanka, from 1974 to 2019, based on that period, we can say every year there can be 12 people died due to lightning and 11 people could be get injured, right? So, and according to the population, 0.56 people per million per year were killed, right? But you can see in the red color text from 2000 to 2019, the recent 2 decades, these values were increased. According to that, every year, 18 people may get killed or 16 people may get injured in a year due to lightning, right? So is it due to some kind of climate change, right? So I'm at the last 2 slides for the today's presentation. So what I want to emphasize here is, here now we talk about the rainfall increasement, and here you can see the number of lightning flashes from 1980 to 2014 also increasing, right? So you can see here the figure A from 1998 and the lower it 1994, 2014. So it is different, it is changing, right? So those are the information I want to discuss with you. So I am not going to give you the answer for this question, is climate change happening? Now I'm going to let you to decide based on this information whether from Sri Lankan context, are we having these evidences, or are we having these experiences which can contribute significantly to figure out the answer? So with that, I'll stop for the session. Hope we can have a nice discussion session. So thank you very much for listening.
Thank you, Dr. Indrasinghe. I think it's a very you're very well on time. Thank you for finishing it on time, and it's a very interesting topic as well. And maybe I'm not sure, maybe less research topic, but lightning is certainly and one of the interesting areas for discussions. So I'm sure people will have more questions, maybe from different countries in South Asia, how the lightning is seen in their countries and what are the kind of data we have in other countries. So please post your questions in the chat box. We will take those questions at the end of the next 2 presentations. So when you have questions fresh in mind just during the presentation, please post it. We'll take everything at the end for the final discussion.
Yeah. So thank you, Dr. Aslam. Actually, Dr. Madhuranga and Niranga, my PhD students, are also here. So definitely they can contribute during the discussion based on the questions. Thank you.
Right. Thank you again, Dr. Indrasinghe, for that very interesting presentation and with a lot of kind of information, with a lot of new kind of data for us to discuss further in relation to lightning and other climate change events based on Sri Lankan study. So let us now move to the second presentation. So second presentation is on climate change in South Asia, current status, projections, and sectoral risks, which will be delivered by Mr. Bahan. Mr. Bahan, are you there?
Yeah, good evening.
Good evening. Let me introduce first before you move to your presentation. So Mr. Bahan is a regional coordinator, agrometeorology, and head of power, health, and transport sector application at the India Meteorological Department in New Delhi. He holds MSc in agriculture meteorology from Haryana Agriculture University. He completed in 1988 by securing top position in MSc in the university. He is also a joint secretary of the Indian Meteorological Society for 4 years and is elected vice president of the society for 2 years. And he established the location-specific weather information and forecast system in the country during the Commonwealth Games in 2010 in New Delhi, the first of its kind in the country, and the heat health early warning system in India. And he has more than 80 research papers in peer-reviewed national and international journals. And also he authored 4 books. 3 of his papers have also won the Best Paper Awards. So with that brief introduction, let me invite Mr. Bohan for his presentation.
Thank you, Dr. Aslam. Thank you very much. And also I thank the organizers, particularly Dr. Novil as his team for, inviting me here and giving this opportunity to discuss with a much wider audience here. And today, will I be able to share, Dr. Aslam?
Yes, you will be able to share your screen, I think.
You can share. Yes.
Is it visible?
Yes, it's visible. Yes.
Thank you. I'm trying to make it full screen, if possible. Yeah.
Yeah, that's perfect. Yes.
Thank you very much again. And after a very elaborate and very specific and very useful presentation from Dr. Mahesh, I'm more on a generalized aspects of climate change in the South Asian region. What is the current status? What are the projections? And what are the risks for different sectors of economy? And climate change, though I won't spend much time on this slide, is very much evident from the increasing temperatures. If we see the global mean temperatures here, the last 30-year period from last decade of the previous century and 2 decades of this century, the warmest 30-year record in last 500 years. Each of last 4 decades have been warmer than previous decades. So it's constantly rising, has increased or by slightly less than a degree in last 100 years or so. So that's the most evident evidence of that climate is changing in terms of temperature. And the global observations, if you see here, this is the temperature that has increased. The ice cover, particularly in the Arctic, is going down. The Antarctic ice shows a little stabilization in the recent past, but Arctic ice cover has gone down considerably. Sea levels have increased. That's another hazard for us. And if you see the global sea surface temperatures, they've increased over most parts of the globe, except a small pocket over North Atlantic. That's an odd man out of, and I don't know for how long would it hold. Rainfall, though, is showing mixed trends over different areas. It's increasing over some areas, this blue class here in bottom right panel, and it's showing some decreasing tendency in some of the areas. But is it a new thing, increase in temperatures? If we see these estimates of temperature from Vostok Ice Core, Russian station in the Antarctica, estimated for last 400,000 years. The bottom panel shows that we have seen temperatures much warmer than they are now. So is it unusual? And also the same was associated with increased carbon dioxide content. So rise in temperature is not unusual. What is unusual is that with increased scientific knowledge, we have evidence now the increase at present is because of human activities. The past increases were because of natural phenomenon, but current increase in temperature experienced more over last 50 years or so is because of human activities. And IPCC, as we all know, in 2013, concluded that oceans have warmed, amount of ice has diminished, sea levels have risen, and the human influence on the climate system is clear now, and recent anthropogenic emissions of greenhouse gases are highest in the history of the mankind. The current estimates by the World Meteorological Organization issued this year that shows the trend of temperature. the GHG emissions continue to increase in 2019 and also in 2020, this being a COVID year with economic activities at much lower than the normal level, but still the greenhouse gases increased in 2020 also. And despite La Nina conditions, 2020 turned out to be third warmest years in the history. As we all know, it's contributed by the greenhouse gases, the carbon dioxide, methane, nitrous oxide, and some minor gases, the chlorofluorocarbons. If you see the bottom, the top right panel, over last more than 1,500 years, 1,500 years, the concentration was broadly stable for these greenhouse gases. Since middle of the 18th century, when industrial activities started, they started increasing, and they're increasing at a tremendous rate. Pre-industrial estimates of carbon dioxide, if you see, were about 280 ppm, which now has crossed 400. It crossed 400 in 2015, and now it's about 415 ppm. Methane has also increased, nitrous oxide increased tremendously. CFC concentrations have gone down after the Montreal Protocol, but we have introduced new gases, the hydrofluorocarbons. There's totally man-made gases, which are also contributing to greenhouse effect. And the effect we all know is because of imbalance in the radiative energy balance of the Earth. The Earth gets the radiation from the sun, the heat from the sun, in terms of incoming solar radiation, that simultaneously also emits out the radiations. And there was a balance between the two. But this balance is now being disturbed because the envelope around the Earth in form of the atmosphere is becoming more and more opaque to this outgoing long wave radiation. It remains transparent to the incoming radiation. The greenhouse gases restrict some of the radiations going out of the world. So there is a net gain in radiation that is leading to this increase in temperatures. Coming to our area, South Asia, geographically dominated by main 5 broad features, which includes mountains in the north and northwest of the region, highest mountains of the world. There are large floodplains and deltas of 3 major river basins of the Indus in the west, the Ganges in the central parts, and the Brahmaputra in the eastern parts of the country. There's large raised lands in terms of plateau over peninsular India. There are southern islands, starting from Andaman Nicobar Islands in the east, Sri Lanka, Maldives, and the Lakshadweep Islands of India. And there are large coastlines, so mainland South Asia and also the islands put together. And the area is among the most densely populated regions in the world, home to about 1/5 of the population and majority of the poor. Among the most disaster-prone areas, main occupation being agriculture, though its contribution to GDP is progressively going down, and urbanization is fast increasing. That adds to the impacts. If we come to the observed trends in temperature over the region, the top left panel is the mean temperature trend over India, about 0.63 degrees Celsius over last 100 years, and most of these years after 1990 have been warmer than the historical average. Similar trend, a nearly similar trend is for Pakistan, though the data sets are different. It starts from 1960, Indian data set are from 1901 onwards, but the rise here also is from 1990 onwards. Here also exactly from 1990. Mean annual temperature of Nepal is increasing at much higher rate because the mountains are warming at considerably high rates. Annual maximum temperature, this is for Dhaka, this also is increasing. Temperature trends, Sri Lanka are showing a significant warming trend. And heat waves, this is for annual heat wave days over India in different years. If you see, the red years are the El Nino years and the green ones are the La Nina years. Out of 14 El Nino years, 9 were warmer than usual, whereas out of 12 La Nina years, only 3 were warmer. So the global features are also having impact in the region. And the heat wave impacted area in Pakistan, as shown here, is increasing. So all aspects of temperature are increasing over the area. But there are some regional, seasonal and regional differences. The top left panel is for Pakistan. This blue one is the increase in temperature from 1960 to 2007 for winter season. And this yellow on the right-hand side is for annual, and middle is for the summer season. If you see for all the areas, temperatures are increasing. They are increasing more in winters, except the northwestern province, the Khyber Pakhtunkhwa of Pakistan, where the summer temperatures are showing slightly decreasing trends. Otherwise, it's all increasing everywhere. And nearly similar trend for India. If these are the temperatures for last 5 years of 13 to 17. Winter months have been more warmer compared to summer and monsoon months. So that shows highest warming in the, and it's true for other countries of the region also. So the highest warming is observed in the winter months, and that has implication including early onset of the heat stress, widening of favorable windows for pests and diseases, both human and agriculture, and also animal husbandry. The water demand starts increasing earlier. That puts additional stress on the water resources before the onset of monsoon season. So this seasonal discrepancies are also having their impact in the region. And if you see the trend in South Asian countries, a very beautifully reviewed paper of Namindra Kumara and others in 2019. He's from University of Paradenia. I think it is in central parts of Sri Lanka, if I'm not wrong. They've done extensive review of temperature trends in the region, and the salient features are as follows. The temperature has increased for all the regions, for most of all the seasons and for most of the regions, with greater trends during post-southwest monsoon season and winter seasons. That has an implication that the southwest monsoon soil moisture starts decreasing at much faster rates for agriculture and drinking water purposes. Temperature of the warmest days and coldest nights have increased across the region. Heat waves have increased, cold waves have decreased. Heat waves are now setting in much earlier in the season. They started from the month of March, where they used to start in April, and cold days and cool nights are reducing across the region. That's the gist of the temperature trends of South Asian countries. And precipitation trend from the same paper, if we see, it shows an increase in very wet days. That is days above 95th percentile. Number of days of heavy rainfall or high intensity rainfall are increasing. Weekly and monthly largest rainfall, largest annual, highest weekly and highest monthly total rains are also increasing. Consecutive dry days are also increasing, which means larger interspell duration is increasing. Dry interspell, though wet days are increasing, but the interspell duration is also increasing. And decrease in wet days, contribution of snow to total precipitation is decreasing. That's also an important finding. It's more of liquid precipitation is falling in the Himalayas now compared to earlier. And total precipitation is either trendless or has shown some increasing tendency, as shown by Dr. Mahesh just before this presentation. It's showing some increasing tendency at most of the places, not very statistically significant, and it also trendless at many places. And this is another paper by the same set of authors appearing in another journal a year ago, that is in 2018, that describes beautifully the rainfall variability. And Dr. Mahesh also pointed out towards that. On the right-hand side panel is the total seasonal trends of Sri Lanka. These red triangles, if you can see, are the rising trends. The solid ones are significantly increasing, and the hollow ones are increasing, but not very statistically significant. The blue circles are the decreasing tendency, not significant, and the dark blue circles are significantly decreasing tendency. If we come to the right panel first, the seasonal rainfall in Sri Lanka is increasing in most of the places. But if you see the number of wet days, they are going down at most of the places. That shows that most of the rainfall, though their rainfall is increasing, the wet days are going down. So most of the rainfall is now falling in less number of days. That means more intense rainfall is happening now, and there are more dry days in between. So intensity of rainfall is increasing. And that also was found true for India. This is a paper by Goswami and others in Science in 2006. This green one are the low and moderate rainfall events. They are going down over a period of time. Whereas the blue ones are heavy rainfall events, that is up more than 100 millimeters per day. And the red ones are very heavy rain events that more than 150 millimeters per day. Those rains are increasing. though the total rainfall for India is trendless, but heavier rainfall is increasing. And this increase is not uniformly distributed across the country. This top panel on the right-hand side shows the red places are where red and yellow, where it's increasing, the heavier rainfall events, but there are places where it's going down, particularly in the northern parts of the country. And the total June, July, August rainfall, which is the main rainy season for India, though total countrywide rainfall is not showing very significant trend, but there are areas. The red ones are the areas where rainfall is decreasing. The blue one are the areas where rainfall is increasing over in last 100 years. And the impact of this increase in heavy rainfall event is reflected in frequency of the severe floods in India. This is for last about 35 years. They are constantly increasing over the period. So flooding is more because more intense rains are happening. If you see the monsoon is relatively stable, though there is large interannual variability, but the monsoon rainfall as a whole over India has remained broadly stable. But there seems to be some cyclicity. The years of low rainfall, they tend to club in a period. Say 1901 to 1920 was one period where there were many droughts clubbed together. From 1920 to 1960, there were less droughts. There were not so many. The red bars are the droughts. Then again, from mid 60s to mid 80s up to 87, there were very frequent low rainfall events. After that, there were. So there seems to be some cyclicity in monsoon, but it's trendless. And for the region as a whole, if we see what does IPCC says, the left panel are the trends in annual temperature and rainfall of the region for last about 100 years, and rainfall for the last about 160 years. The temperature is increased out most of the places. The rainfall has increased or decreased at different parts of the area. Sri Lanka is showing decrease. That may be because of the data sets. Different data sets lead to different kind of findings. Localized data gives us far better insight for local actions. But if you see the projections on the right-hand side, this is for different concentration pathways. 8.5 is the business as usual pathway. For mid-21st century, this is the temperature rise across all the region, and late 21st century, tremendous rise. If we can restrict the emissions to lower levels, which is the RCP 2.6, the increase will be much lower. And coming to rainfall, if we see RCP 8.5, almost all parts of South Asia are showing significant increase by late 21st century, second half of 21st century. The blue are significantly increasing, and blue hatched are increasing, but not significantly. The entire area rainfall is expected to increase as per the projections. And for India, the heat wave days during summers are projected to increase. The 2050 to 60, this is the number of increase in heat wave days over different parts of the country. Nowhere it's showing decrease. And 2080 to 29, last decade of this century, is expected to have many more, up to more than 30 heat wave days per year are expected to increase over large parts of the country here. Similar is number of days above 45 degrees Celsius, is the same thing. Number of extreme rainfall events of more than 100 millimeter a day are also expected to increase towards end of the century. This part, central parts of the country and northeastern parts of the country are expected to increase. But then what are the risks to different sectors of economy? The first and foremost sector, though its contribution to economy is going down, but as far as employment is concerned, still agriculture is the sector which implies maximum number of people in the region, and major impacts of this increase in temperature and variability of rainfall would be through increase in water demands of the crop. The growing season over most of the areas would shrinken. Smaller growing season would be available to the crops, though it may increase in the hilly areas. But chilling hours, which are needed for some of the winter orchard crops, particularly that will go down, which will adversely impact the yields. Damage due to severe weather events, floods and droughts would increase. New pests and diseases may come, and the existing one may spread to newer areas. A major change would be on rain-fed agriculture, which is by mostly the poorest of the farmers. Loss in farm level revenue are estimated for India. This is for India between 9 and 25% for temperature increases. There will be nutritional implications because there will be adverse impact on food grain availability, particularly coarse food grains, which are mostly grain-fed and they are more nutritious than wheat and rice, but they are also consumed by the poor. More impacted. Seeds, oilseeds, they would also decrease. A decrease in purchase power of the poor due to adverse impact on other sectors of livelihood would also, limit the ability of the purchase power of the poor. And agriculture insurance cost go up. Continuing with agriculture, the productivity cereal would decline. Global decline is expected to be 40%. Winter crop, because temperature is rising more, so they are expected to be impacted more. And more incidents of both droughts and floods, that would impact the agriculture production, increase the variability, and there would be considerable. Oh, is somebody speaking? And considerable impact would be on the pathogens, microbes, insect pests, in terms of increased incidence, new pests. And important is that there may be imbalance in food trade due to positive impacts on some of the northern parts of the world, particularly Europe, North America, and negative impacts in South Asia. And continuing with agriculture, the increasing temperature would increase the fertilizer requirements for the same production targets. Increase of sea levels and river water is likely to affect the fishing, the migration of the fish and fish harvest. Coastal erosion would increase water, shelter, and energy requirements. Seasonality of the crop may change, and this is a very recent report appeared yesterday. Perhaps the cherry trees peak blossom in Kyoto, Japan this year was earliest on record for last 1,200 years, and this follows a usual pattern where the cherry blossom is blossoming earlier with each year, and this year the blossoms in Washington DC is also peaked several days ahead of their 30-year average period. So agriculture seasonality would also be impacted, and this has implication for tourism also. But there could be some possible beneficial impacts also of climate change. The reduced frequency of frost damage, particularly in the colder areas, would help the crops. New flooded areas may become available for fisheries in the coastal regions, and maybe there could other potential impact, but they need to be characterized better through research. Water resources would be impacted mostly adversely. The increased glacier melt may increase water availability initially, but eventually it will go down. Increased risk of flooding would be there, and increased water flow caused by intense rains and associated with increased silt content will impact the hydro energy generation. Risk of floods and droughts would increase. The quality and quantity of water available for agriculture and domestic use, vector-borne and waterborne diseases, and also zoonotic diseases may increase. It will adversely impact the ecosystems, and it will have impacts of various scales on water supply infrastructure also in terms of physical damage. On health, it's very evident that heat waves are increasing. So there would be increased incidence of heat waves and associated illness, motility, morbidity, loss of livelihood. The water and vector-borne diseases would increase, and diseases are expected to spread to newer areas. The model shows that malaria, which is confined to some parts of the country, now would increase to newer areas. The windows would be much wider, where it's prevalent for 6 months. Now the projections show the malaria would occur for 9 to 10 months in second half of the century. Non-communicable diseases also particularly hurt, and the COPDs are expected to increase with increase in temperatures. Loss of livelihood and life associated with the natural disasters would increase. The cost of health and life insurance would go, and demand for healthcare services would be under stress in terms of public health programs, disease prevention activities. Requirement of healthcare personnel would increase, infrastructure would be under pressure, and supplies related to treatment would also come under severe pressure in changed climate scenario. Disaster, we all know, increased incidence of heat waves, severe and more frequent thunderstorms, intense monsoon rains would lead to more floods. Longer interspell durations will be there during monsoon, adversely impacting the agriculture. The tropical cyclones, though the trend in the North Indian Ocean does not show increasing trend, but the intenser cyclones, the more intense cyclones are increasing over the period. We were not having history of super cyclones, but over the last 10 years, there have been 4 super cyclones in the North Indian Oceans. Cyclone season is becoming longer. They're starting much earlier in the season, coming right up to, we have history of, for January also now having tropical cyclones. Sea level inundation would have its implication on coastal infrastructure, residential buildings, livelihood of the fishing community. Urban floods have increased, and they would increase further due to combined impact of increased urbanization and more intense rainfalls. And landslide, mudslides, gulfs, they would increase. Energy demand for heating would go down tremendously. We are more concerned about the cooling, that would increase, though the heating requirement may go down. But because our requirements are more for cooling, that would increase. And efficiency of thermal conversion as a result of rising temperatures goes down. Transmission efficiency also goes down with increasing temperatures, that is being implicated. Hydro energy in terms of increased silt and more intense flow, the run-off river projects would also be impacted by intense rainfalls. And grid failures may become a more regular phenomenon than it is now because of increased failure due to increasing demand due to rising temperatures, and also physical damage to the infrastructure caused by intense thunderstorms and other type of severe weather activities. Tourism, transport, all type of transport, as we know, are vulnerable to extreme weather events, including human injury and loss of life. Transport vehicles and other infrastructures would damage to that would increase, and deferred schedules, and it will have their economic implications. Infrastructure in the hill is more vulnerable to freeze-thaw cycles also, and road and rail lines are particularly vulnerable to temperature and rainfall extremes. Tourism may be impacted, particularly the resorts and skiing and beach resorts. There may be shifted, the people's choice may be shifted to more cooler places, higher latitudes and colder countries, impacting the tourism sector. If we continue with future, how much time do I have, Dr. Novi? Oh, I have it. Sure. So,
yeah.
Another
Go ahead.
Not more than 5 minutes, I think.
Yeah.
Okay. So the climate change will amplify the existing risks and create the new ones. And risks are not evenly distributed, which is more important. And they are generally greater for the disadvantaged people and the poor communities. Even if we stop the anthropogenic emissions, the impact of the current emissions would continue for much longer time, is going to be there with us. And the future pathways are for adaptation and mitigation, which are complementary strategies for reducing the impacts of climate change. And emission reductions with the next few decades can reduce the risks associated with climate in much longer future. And how do we adapt to climate change? Basically 3 strategies. We need to invest in research, adaptation, mitigation strategy, and capacity building. We need to change the policies, giving incentives for resource conservation, resource use efficiency. The pricing of resources have to be regulated. And then use of weather and climate information and other risk management interventions have to be integrated with overall disaster management and public education strategies. And adaptation and mitigation measures are more important in the developing world because the sectoral production and management systems are far more articulated in developed countries in terms of their generation, transfer of knowledge and actions. Whereas in the developing world, they're still evolving and rather weakly linked with end users. There is greater heterogeneity in the production and of the information and its used by the end users. use of information technology is relatively lower, and introduction, dissemination of the knowledge and search for new knowledge is relatively at low level, and probably we are making efforts for that, and today's discussion is perhaps a contribution towards that. Coming to country-specific actions in the region, COP16 at Cancun, that was 2010, they produced the basis for most comprehensive international response to climate change in terms of to commit the maximum temperature rise to 2 degrees Celsius above pre-industrial level, and also limiting it to 1.5. This is important because in a matter of 5 years only, in 2015 at Paris, we came down heavily on this 2 degrees Celsius. That is going to have severe implications. We need to restrict it to 1.5 degrees Celsius. And based on the resolution of Cancun, all the countries in the region have made their national adaptation plans for climate change. This is for Bangladesh, Bhutan, this is India, this is Maldives. I don't know what is this country. Okay. This is Sri Lanka, and Pakistan, they are perhaps in the process, but the information I got, they are in the process of making it. But they have in their initial national communication on climate change identified the priority areas. They have a separate Ministry of Climate Change, so the country is working on that also. The entire region is working. And specifically coming to India, the National Action Plan calls for 8 missions for increasing energy use efficiency and bringing down the impacts of climate change on the society. That includes the National Solar Mission, the Mission for Enhanced Energy Efficiency, a National Mission for Sustainable Habitat, Water Mission, and a National Mission for Sustaining the Himalayan ecosystem, which is very fragile and more prone to climate change. Green India Mission, and a National Mission for Sustainable Agriculture, and a National Mission for Strategic Knowledge for Climate Change. We involve a lot of institutions and academia for generating knowledge on climate change. And 2 years ago, 2 new missions have been added to that, National Mission on Human Health and National Mission for Climate Coastal Zones. So the country is working on different aspects, and I think last 2 slides, and some of the actions, if you see in India, the Renewable Energy Program, we have a target of 175 gigawatt till 2022 and 450 gigawatt by 2023. And at present, about a quarter of the installed energy of 370 gigawatt of India comes from renewable sources. Electric vehicles are being introduced in a big way, with a lot of incentives being given for those vehicles. And we have a target by 2022 next year and 10 billion square feet of green buildings. And out of that, 750 million square feet are already. And we have different cities and states. And we now have heat action plans for 17 states in the core heat zone of the country and 130 cities. And the impact of this heat action plan can be seen here, bottom left panel. These are the annual heat wave related mortalities per year, which showed an increasing trend up to 2015. And then we had a national guidelines on heat action, and national action plan was prepared. And since then it's coming down. The last year, 2020, there were only 4 heat related casualties reported, though it was a COVID year. Maybe the numbers were less than usual, but still showing a very significant decreasing trend. And the top right panel shows a report from BBC that in 2022, for the first time, India's carbon dioxide emissions have fallen for the first time since 1982. And this statistics from World Economic Forum shows the additions of energy sources. This red or I don't know, pink bars are from coal. So addition from coal sources is going down. This is 16, 17, and this is 2018. And addition of green energy, this green one is from total of wind and solar, that is going up. So the country is taking impacts. And that is reflected in the carbon dioxide emissions also here in the top panel. So if you conclude, climate change is a reality. Almost all sectors are likely to be impacted, most of them adversely. Adaptation and mitigation can help us minimize. We need to have planning, research, and policy support for that. And cost of adaptation and mitigations are really not known at this stage, but they are certainly going to be less than the cost of inaction if you don't take any actions. So we need to start with no regret adaptation mitigations. They will have positive impacts than not having any actions. And this is perhaps the last slide, climate change at zero tolerance, I would say. This is today's report, which appeared in the Science News. These are the lightning incidences over Antarctica. Even at a remote place, which was not so prone to lightning, they have increased over the last 10 years tremendously. So frequency of lightning strikes from the Worldwide Lightning Location Network from 2010 to 20, the number of stations changed, but this orange dots using the same number of stations show tremendously increasing lightning activities over the remote location of Antarctica. So we all need to contribute towards climate solutions for a bright and safer future. Thank you very much. Thank you.
Thank you, Mr. Ban. Yeah, I think it's really a great presentation with a lot of details covering South Asia and looking at different aspects of climate change. So thank you again for your presentation. We will take more questions. Please put it in the chat box and we will take it in the...
Can I stop sharing Aslam now? Should I stop sharing the slide?
Yeah, so we are going to move to the next presenter.
Stop. Thank you very much.
Yeah, thank you again for your presentation covering very different aspects like from each country in the South Asia, from heat waves to the impact of climate change in each of the sectors, the critical sectors, and as well as some remarks on the National Action Plan as well as the future way forward. So let us now move to the final presenter. It is Mr. Maharam Dakwa, who is going to present on climate resilience in water, agriculture, and health systems from a planning and participation perspective. So let me introduce him. I hope Mr. Maharam is here.
Yeah.
Right.
Good evening. Good evening, Dr. Aslam. Can you hear me?
Yes, we can hear you. Good evening. So let me briefly introduce you before we move to your presentation to our participants. So Maharam is from Bangladesh, and he has BSc and Masters in Civil and Environmental Engineering from Bangladesh University of Engineering Technology. He developed the national guidelines for CRWSP for urban piped water supply systems, which will soon be adopted in the National Water Safety Framework by the government. And currently also he's developing climate resilient water safety plans for climate vulnerable water supply systems and training, and also training the sector professionals in climate resilient water safety plans. He's also a master trainer of training courses on rainwater harvesting system, climate resilient water safety plan, and city-wide inclusive sanitation system. So we have a very variety of different presentations. We looked at lightning in detail in the first presentation, and in the second presentation more into different aspects of climate change. And now we have Maharam, who will be talking more about water, agriculture, and health systems. So it's over to you, Maharam. Please post questions in the chat box. We will move to the discussion after this session.
Thank you, Dr. Aslam. It is a pleasure here to be with you. Am I audible?
Yes, we can hear you. You can share your screen as well.
Okay. Just a second. So you can hear my screen now?
Yeah, we can see your slides. Please go ahead.
Okay. thank you again. Thank you so much for having me here. I can see it's a group of people who have been working in different sectors, and one common thing is everyone is focused on climate change, which is very good. But first two presentations, I learned a lot from the presenters, and also thank you all for having me. I am a civil engineer working in wash sector. Wash, we normally use this to shortly say it is water supply, sanitation, and hygiene. So my main focus area is water supply and sanitation. It has been okay. Can you all see the slides?
Yes, yes, we can see the slides. Yes.
Okay, okay. So when I start talking about climate change, first I need to say that I'm actually not going to show what I mean the magnitude of climate change or how much it has been changing. What I am going to focus on in my session is what the people who are actually getting affected, the receivers of the consequences, and how they feel about it, and what our government and academia and industry they have been doing to address this issue. So as I said earlier that my main focus will be the water sector, but you all know that agriculture is very much dependent on water, and also the health system. It has a huge relationship with water availability, quantity-wise and quality-wise both. So before I get into the impacts that our people are experiencing now, just to give you an overview of the current scenario as far as climate change is concerned. So there are many ways of trying to prove how the climate is changing. I think we already know that climate is the long-term average of weather. So when we talk to people and ask them about how the weather is, I think people nowadays complain so much about the rise in temperature and the pattern of rainfall that has changed, and the prolonged drought and floods. So these are the things that we get to know from people. But when we talk about climate change, it is important to understand actually how much change has happened in the last few years or few decades. So as a professional, when I go to my study areas or project sites, I find it a very useful way to understand what are the changes, what difference they can feel. And when I ask people who have been living there for 2-3 decades, they sometimes share very interesting thoughts and feelings. For example, we all are now complaining about the rise in temperature. So when you ask someone who is 60 years and 70 years old, I think he can tell you how the climate or how the temperature is changing over the last 4 or 5 decades. So what he felt when he was 30 and what he feels now when he is 70 or 60. Actually, that gives you a real life example of how it has been changing. So we all can see nowadays through different models and analysis that, okay, temperature has increased on average by 2 degrees Celsius or 4 degrees Celsius, depending on where you are living. But the people who are actually suffering from the effects of climate change, it is also important to understand how they feel about it and how they're taking about it. Because if people, they are they are kind of okay with what the change is right now, then I think it is also a message about the resilience of the people. So what I actually do when I go to field, I try to learn from the local people how their understanding is about the change in temperature, or the rainfall, and the drought, the prolonged flood, or the sea level rise, salinity. We all know that these are the main symptoms that we identified as the result of climate change. So I think we already know about this, the difference between weather and climate. So sometimes when we talk about the climate change, people often get confused between weather and climate. But you already heard from the last presentation that climate is something that is the average weather over a period of 30 years or more. So when we discuss about the climate change impacts in Bangladesh, there are few things that we should discuss first. One of them is floods, and which is not only the consequence of climate change in Bangladesh, because there are so many issues. There are transboundary river issues, and there is sedimentation issue. So it is actually difficult to tell that the flooding is only the consequence of climate change. But one can easily understand by analyzing the river flows that the flood nowadays, the prolonged period of flooding is one of the consequences of climate change. In Bangladesh, you can see a map here, right side, though it is a salinity map, but I thought this would be useful to explain how the different parts of the country are affected by floods and droughts and salinity and other issues. So when we talk about flood, mostly the middle part of the country and the northern part, these areas are mostly affected by floods. And normally we have floods during July, August, September, and for last 4 or 5 years, it has been 5-6 weeks long at least, which was not the case before this decade. So now we can see that Bangladesh is experiencing a prolonged flood in this decade. And also we have this drought issue, which is very significant for us because the agriculture system, it depends on water supply. So when you have a prolonged period of drought, it really affects your crop calendar and cropping pattern. I will talk about this later, that in some part of the country, people have been forced to change their cropping culture. They used to harvest 3 crops in a year, but now because of the lack of availability of fresh water during some period, they are now forced to harvest 2 crops in a year. And cyclones and storm surges, I think Bangladesh is a bit of a country that is familiar with this. And in last 4 or 5 years, almost every year, we were hit by cyclones. The biggest one was in 2007 and 2009, but after that, almost once in a year or once in 2 years, we have been hit by large cyclones and storm surges. And in addition, there is the consequence of sea level rise. You can see the southern part of Bangladesh. It is very much affected by the salinity. The groundwater has become saline in so many districts, and that really is pressurizing the already scarce water source in the country. So now when we talk about the impact, I think the first thing that comes in our mind that who are the people who are most affected by climate change, and what is the magnitude of the effect. Bangladesh, like many other countries, is a country that is getting more urban. People are becoming more reliant on technologies, and the rapid rate of urbanization has been showing its effect on the landscape and behavior also. It's a very small country, but a lot of people. So when we have a lot of people in a very small area, one can understand that once there is any effect, it actually affects a large number of people. So one of the big things happened in Bangladesh is the migration, and we call it climate refugees, especially the southern part of the country, the Khulna division, and there are a few districts, Khulna, Satkira, Bagirhat, and these are the areas that are most affected by the tidal surges and cyclones and salinity. So if you go there, you will find that many people who used to live in the villages now are moving towards the city areas, the municipality areas, and even coming to Dhaka, the capital. So migration is a big problem, and because of flood, river erosion, you will find that in Dhaka, the capital, there are so many people who came here because they became landless. Because of the land erosion and the flooding, and maybe they have lost the livelihoods. So these are the main things that that really caused them or resulted in their migration towards the urban areas. Also, the ecosystem, it was largely affected. And I'm not going to talk about a lot about the ecosystem. And there are many other sectors like communication, transportation, they get affected by climate change. But my main focus is the water sector. It is very important, as we all know, that any civilization or any neighborhood or anything must be established in an area where water is available. There is abundance of fresh water. So Bangladesh is a country where you will find almost in every areas there is a groundwater source. Though the quality of water is not up to the drinking water level, but you will find water everywhere. But with the change of climate, and also due to the behavior of people, as now we are becoming more urban and the demand of water has grown up. So people are trying to extract more water from the aquifers. But at the same time, the rate of recharge of groundwater is not that high, and which is exacerbated by the fact that nowadays we have a long summer. Previously, we used to have a rain during March, April, but nowadays it is almost May, the last part of the May, that we get the rain. So people are trying to extract more water, trying to get more water, but unfortunately, the number of dry days has increased and the rainfall pattern has changed. So during the period from March to May, almost all municipalities you will find they're starving for fresh water. So that is really affecting the lifestyle. So that is one effect of a long summer period in Bangladesh. But in addition, there is another problem, as you can see from the map here, the southern part of Bangladesh. So the water is very saline there. So the groundwater, it is very saline. So although you have water everywhere, but unfortunately, this water is not potable. So which is one of the main reasons why people in this area, they are trying to shift towards the municipality areas or towards Dhaka, the capital. So what they are doing in this area, they're actually relying on rainwater. So that is one major area where the use of rainwater is really significant in Bangladesh, because there is no other option. Surface water is saline and groundwater is saline. So only source you have is rainwater. But maybe you know that rainwater harvesting is not that easy, because it depends on the rainfall pattern. And as I said earlier, that the rainfall pattern has changed. Now you have a shorter rainy season, maybe that starts from the mid part of the May and lasts until the end of September. So now they need to store water for 6-7 months. So when you have higher demand, you need a rainwater storage system of higher capacity, higher volume, and that is really costly. And people, especially the poor people, they cannot afford it. So they are actually feeling the effect of this changing rainfall pattern, and they're really suffering, and the health system is also suffering. And if you go to this area, I was visiting last month, and I was in the Upazila health complex, that is the sub-district level health complex, and the civil surgeon was there, and he was telling that in last month we had 500 cases of diarrhea. So and he said that this is a very common case when every year during the month of February, March, April, the number of diarrheal cases increases significantly. And he said this is due to drinking unsafe water that they fetch from the canals and the ponds, and maybe because of not knowing how to preserve rainwater. But this is actually the impact of this changed rainfall pattern, or the prolonged dry season. Nowadays, people use this term, climate sensitive disease, CSD. So diarrhea, malaria, these are the diseases that we know have been in our society for so long. But now with the effect of high temperature and the changed rainfall pattern, the health system has been affected a lot, and especially during this period of the year from March to May, you will see the number of cases in the hospital rising very high. So this is from the domestic water use perspective. If you look at the use of agriculture, water in agriculture sector, you'll also find a similar scenario. I said earlier that in Bangladesh, there are so many people who are actually dependent on agriculture, and they still try to harvest 3 crops in a year. But unfortunately, due to non-availability of water for irrigation, they had to abandon. And nowadays, they are forced to go for 2 crops in a year. Sometimes in some areas, they had to abandon a certain crop because it takes a lot of water to grow. So, but they cannot afford to bring water through canals or any other sources. So they had to abandon that crop, though it was very profitable for them. It has some other sides also. For example, in the southern part, if you go there and you will see that so much people are interested in shrimp farming because this is a saltwater species. So in last 5-7 years, so many people, they have showed interest to grow shrimp in their ponds and lakes and canals. And this is maybe a profitable business for many people, but it is coming at the expense of the quality of the land, because when you let saline water in, then the soil will become saline and you will never be able to grow any vegetable or any crops there. So government has been trying to solve this issue, but the shrimp farming is a very profitable business. So this is an issue that actually benefiting a little number of people in that part, but most of the people who are villagers and poor people, they are getting affected from this. So this is another side. So when you talk about the agriculture water, another thing that comes to mind is the flooding, because some of the crops, they need water, but when it is a prolonged flood, then it doesn't bring any good result for the farmers. And every year we can see that so many thousand hectares of land cannot yield crops because of the flood water. So the things are really complex, and we often talk about resilience and adaptation. Bangladesh government has been trying in different ways, but it has been a case that we have money, we have projects, but unfortunately there hasn't been a framework or a successful modality of implementing the projects that can solve the many issues that people have been facing. So we often talk about the policy plan and program, and they need to come up together to work well for the people who are actually getting affected. But we have a policy 2009 PCC SAP, but unfortunately when we start planning, we cannot follow the policy because there are so many things coming up, new issues coming up, so there are gaps. And when it comes to program, the policymakers, they often look for the short-term outcomes. I think people who are involved in projects, we will agree that when we design a program or a project, we often try to show that, okay, after 2 years, after 3 years, we need to see this outcome. But sometimes it takes time and it's a long process because some of the changes are not tangible. It takes time to show up the outcomes. So when you discuss about the policy plan and program, there are many gaps that we need to address. And that is from the planning perspective. Just one example I might share with you. I'd like to share with you that in the southern part of the country, Satkira Khulna, there was one project when the government wanted to install a desalination plant. So as I told you earlier, that this part of the country, it is very much saline affected. So people have been relying on rainwater, and rainwater cannot give you a lot of water. It just gives you enough. But when we take up new projects, we often try to solve the problem with one single project. So government wanted to invest a lot of money in the south, and the department and they hired consultants and they installed a desalination plant. And it worked very well for first few months. But after that, when the project ends, there is no one to look after the plant, and the operation and maintenance cost is very high. I think you know that the rich Arab countries and the Western world, these are the places where you will find some successful desalination plants. But unfortunately, Bangladesh, the municipal authorities and the village committees, they could not afford to run the plant. And after a few months of operation, the whole project was a failure. So sometimes when we plan and when we take up new projects, we are in so much hurry that we want to see the outcome in 1 or 2 years, which is actually not practical. So I think patience is very important, and planning is very important. And another thing is the participation of the community, because nowadays we see the word innovation, and everyone is trying to come up with some innovation and thinking that, okay, I have got the solution. But it is important to understand how people are going to react, and how the people who are actually the beneficiary of the system, how they are going to use it, and are they capable enough to operate and maintain the system. So considering all these, I think it is very important that we think about the community, and the engagement of the community is given importance, because some of the solutions that we can see is working. For example, rainwater harvesting. It is very easy to use, and the community is very familiar with this solution, and without any external support, they can continue using it. So I think it is very important that whatever support we get from government or the big donors like World Bank, ADB, they have been investing a lot in Bangladesh, but it is very important that we plan well, we have the right policy, and the programs are taken in line with the policy and plan. And in that case, it is very important that the government, industry, and academia, they work together, because we all know that government, they want to support the people, the needy people, and that's what they are for. And there is academia who actually has the knowledge how to do it, and there is industry like the sector professionals. They have been working, and they have been taking up new projects. But it is important that we cooperate with each other. Like government, they need to listen to the academia, because they know what is happening and what is going to happen. They can give suggestions, and also industry, they need to invest where it would be most beneficial. So I think this is very important, and this is why we need to talk together, so that we can have we can have someone who can play the bridging role between this government, industry, and academia. I think this is very important. So is my time up?
Thank you, Haram. So Haram, for your presentation, and giving us more details that are happening and about your work in Bangladesh on climate resilience and climate change adaptation, and particularly some interesting point on migration, conflicts due to climate change issues, and also some other major problems specific maybe to Bangladesh, like salinity, much more problems than maybe in other countries, and also climate sensitive diseases that you talked about, and also finally emphasizing the point of working together with the government and also industry, and the collaboration with the academia. So that will conclude our all presentations, and so it's time for our dialogue, and we're running out of time, but we make sure that we give some time for the participants to talk. So there are a few questions that are posted. So I will just start with them quickly. Some of the answers are there. So thank you again, Maharam, for your time. So the first two questions to Dr. Edelsinger on related to, I think it's related to lightning. The second question. The first is about, are there any studies done or data available in Sri Lanka on the relationship between temperature variability and precipitation events in Sri Lanka during the past few years? And the second question is on, can we see the similar trends in Southeast Asian countries? If not, is this something to do with the island nature? I think the second question related to lightning. Dr. Edelsinger?
Yeah, thank you for these questions. So the first one, actually, I'm not sure whether there are some reports based on these relationships. So the question is whether there is a relationship between the temperature variability and the precipitation. I'm not sure. As far as I remember, it is not there, but it may be a very good study. So we can think about that.
Okay, yeah.
But there are some case studies. For example, for a particular rainfall station-based data, where and even the mid department, they are having the temperature. So there were some case studies based on certain places, but as a country or as a special variable study, I am not sure it is reported.
Okay, right. Thanks, Dr. Singh. And the second question, I think it's related to lightning. Are there any comparable studies in South Asian region, or do you have any idea?
Yeah, actually, it's a good question. It is like this now. South Asian region, basically, we are in the tropical region. So in the tropics, maybe the lightning activities are almost like in a similar trend. But lightning accidents, I'm not sure. And definitely, being as an island, in Sri Lanka, we are having a specific lightning variation. But in a way, you will have a same kind of trend, but the variable pattern, for example, in monsoon seasons, you will have similar like lightning occurrence as well as definitely these lightning accidents. But I'm not sure whether it will follow the same trend. I have seen in India also there were some publications, but again, it's a good study to work as a team.
Okay, thank you, Dr. Singh. I think there are a lot of scope for research in these areas, as far as I can hear from you. So thank you again. Let's now move to the questions to Mr. Ban. There are two questions. I'm sure you have posted many documents in the chat box, so I think people can refer those. But if you want to say something on those two questions, first is on psychological effects of weather. I think it's about heat stress, and second is about non-communicable diseases.
Thank you, Dr. Aslam. There are quite a good number of studies available, particularly in the Western countries, on the impact of climate, stressed climate episodes and the mental stress. They are really lacking in our region, but the stress caused by changing climate and the extreme events is likely to impact the livelihood of the people to a great extent. And that is putting mental stress. And there are records in India, farmer suicide going up. But that needs to be related to climate variability. Some people say that's partly because of rains failing and therefore farmers committing suicide. And that primarily because of mental stress. So mental stress is going up. Heart attacks are related to extreme cold and extreme hot weather. That's established studies are available for that. And the COPD, the congenital pulmonary diseases. Primarily, the air quality is having an impact, and air quality is also related to climate change. The air quality is having impact on this respiratory diseases. Those are well established, and we had a study. I think I can ask the person in the All India Institute of Medical Sciences here in Delhi. They could relate the arthritis with the increased air pollution in the city. The people living in the areas more polluted were found to be more likely get rheumatic arthritis than those living in the cleaner parts of the city. That study is available, was done about 4 or 5 years ago. Maybe I'll ask the researcher there. I know the doctor there. And if you get, I'll share it with Dr. Noble, who can further share with the respondents.
Okay, thank you, Mr. Bhatt, for those responses. Yeah, is there anyone else who wants to ask questions? You can unmute your mic and then you can talk. And yeah, maybe I can just start one question to Mr. Maharam. So you were saying about rainwater harvesting in Bangladesh, and it seems that from your analysis, it's successful, although you said that it's sometimes difficult. But I mean, in Sri Lanka, just a few years back, I kept on hearing that rainwater harvesting systems failed many times, although there were many efforts. So what are the key aspects that you think for successful rainwater harvesting in Bangladesh? Is there anything that is different that you think?
Look, we have rainwater harvesting in the southern part of the country. So as a source of water, the groundwater is saline, so they cannot use it. And the surface water, it is also saline. There are only few ponds where you get fresh water for a few months. So actually, they don't have other options, and which is the main reason they are very much reliant on rainwater. Sometimes the people who have the capacity, they buy rainwater tanks. People that don't have the capacity to buy a tank, they kind of build their tanks with I mean, they are earthen tanks. So this is one part of the country. But when you come to the urban areas like the Dhaka city and the other municipalities, people have many other options. So we have been running this program to encourage people that you need to use rainwater, but the city people, they actually haven't responded because they have other options. So I think it is the natural disasters or being in a situation where they have no other options that actually force the people in south to use rainwater. In whatever capacity they can, they use rainwater. But in city and other areas, actually, it has failed, I would say, that we were not able to encourage or make people use rainwater a lot because it takes a lot of area and the density actually doesn't allow because the roof size you have for a family is very small. So that's the case, actually.
Okay. Yeah, thank you, Mr. Haram, for sharing those thoughts on that.
Dr. Aslam, may I come in for a moment?
Yes, please.
We in the meteorological department have done some studies on rainwater harvesting. I posted that those reports are available online. I posted the link in the chat box.
Right. Thank you for that. Yeah. So yeah, maybe we will close the discussion. So I just wanted to highlight one of the projects that we also have done, myself and Dr. Novel, on the heat health impact, the health impact of heat waves in school children. And also I'm also involved in some other project in the South Asian region on studying the heat wave impacts on woman-headed households. So there, As explained in Mr. Barnes, your presentations, there are a lot of scope for that research as well. There's, I think, still little research is done on the heat waves impact, which seems to be increasing, particularly in the South Asian region as well. If you have any questions, please ask. If not, I have two announcements. Just one is about the one students participants who will be who has participated in this workshop will be selected through a competitive process to get an opportunity to represent the South Asia region to speak at the virtual global webinar. So that is there for the participants from today, tomorrow, and day after. So please tune in and register your participation and keep engaged in the discussion. Second is about you're also welcome to submit case studies, any small communiques, or any experience sharing to the journal that to the journal on International Journal on Community Resilience, where we would welcome real experience sharing, case studies, even small brief research or any other case studies. So please take this opportunity for sharing those your experience, spread the word throughout the world. Right. So I think with that we can conclude the session. So I will ask Dr. Noble, do you have any other announcement, comments? So the second webinar will be tomorrow. So there will be 3 more presenters who will be talking tomorrow on climate change adaptation and mitigation. First presenter will be Charita Rathwata, who is from private sector, Group Sustainability Direct Head at Dialog Dialog, which is a private telecommunication, the largest telecommunication provider in Sri Lanka. Second will be Alahia Rathore, who is an expert in environmental impact assessment from Pakistan. And finally, we have Ibrahim Muhammad, Dr. Ibrahim Muhammad, Deputy Director General, Environmental Protection Agency from Maldives. So today we heard from Sri Lanka, India, and Bangladesh. Tomorrow we have 3 people from Sri Lanka, Pakistan, and Maldives. So it's good to hear from people from different countries, different perspectives on climate change at this time of yeah. So I hope you enjoyed the session. So now I will ask Dr. Noble if you have any more announcements to.
Yeah. Thank you very much, Dr. Saja, for chairing today's session and moderating the session. And thank you very much all the participants. And please bring 1 or 2 friends tomorrow, because it will be very useful to increase the participation. And last but not least, I have to thank 2 people without whom this project would not have been possible. That is our 2 great volunteers for this project, that is Taranga Sachintani and Minoli, who has done extensive work in organizing the project and doing a lot of social media marketing on the project. So thank you very much, Sachintani and Minoli. And also we would like to thank Global Climate Solve Climate by 2030 team for collaborating with us. And the moderator for tomorrow would be Justin Okoli. He's one of our editors. So with that small note, I think we can conclude today's session.
Okay, so thank you, Dr. Noble, and thank you for all the presenters again for very, really interesting presentations and really good perspectives. And I think it has opened a lot of thoughts for new areas of whether research or discussions. They are really interesting and helpful. So thank you again. Thank you all the participants. We look forward to see you again tomorrow.
Thank you, Dr. Aslam, Dr. Novel, and everyone else. Thank you very much.
Thank you. Thank you very much.
Thank you very much.